Hello and welcome to the first ofxATK project video. Today's will be the first video of a new format. I will be starting a project from the very beginning and recording the entire process all the way through. The idea here is that I find the failure when you have a blank project, the failure from beginning to end is actually a very valuable thing to have documented, and is something that can be learned from. Today I will be building a live gesture-controlled vector granulation synth. I'm building this for the electroacoustic ensemble at Ball State University. I will be performing it live on stage, and so that's one reason I'm using gesture control. Gesture control is a visual component. We'll be using a leap motion, which does a very good job and a very reliable job at capturing hand position, location, orientation. Multiple hands, they actually do more than two, but it will do two reliably. And it's very fail-safe. I haven't had any problems with this device before. And also, in addition, somebody has written a library to bring the leap motion into openFrameworks with relative ease, and that will be covered in this tutorial as well. The rest of this title, we covered live, gesture controlled. The vector part of the title is simply stating that we're not going to granulate a single sound file. We'll be stacking sound files vertically, in a hypothetical situation, vertically on top of each other, and we can go through the index as normal, but we can also move through the Y location. So we can, basically it's just a crossfade between various sound files as we granulate these sound files. So we can move temporally and we can move in time, depending on what sound files we decide to use. This is a gesture-controlled instrument, but we are not going to take the gesture part too seriously. We're going to take the low-hanging fruit we can get from the leap motion. This will be the X and Y location of both hands and Z location, the orientation of the palms as a stretch goal, and whether or not the hands are open or closed. So these are good. We're not going to do a sophisticated gesture recognition software in this video. This is one of the more advanced videos I've made so far, and some of these topics I've not covered in videos yet. However, in future tutorials for ofxATK, I will be breaking down the components into a more digestible format for those specific components. So without further ado, let's begin. Let's go to our project generator. Very familiar. Okay, so we'll need some add-ons. I have add-ons linked in the description. We'll need my library ofxATK, or audio toolkit, for the sound. We will use leap motion 2. Now this is important. There is a leap motion 1, and or without a number, and I don't recall that one working. So grab leap motion 2, and I've only tested this on Mac. Let me know in the comments if you have any issues with this on Windows. And we'll also need OFX GUI. We won't be using the GUI in the end, but it will be useful to have this have a GUI to test our variables before trying to use the leap motion to persuade our variables. And that should do that. I'm just going to use an acronym. Call this whatever you would like. And generate. Alright, so we have our project here. Before we do anything, we need to make a plan. This is a fairly large, sophisticated synth. We will be granulating sound files, and this won't be a single stream of grains, but there will be a polyphony, and we can make a number limit for that. But polyphony is fairly challenging, so we'll just need to make a plan. I'm going to open TextEdit as my go-to, and then write some stuff down. So what do we need to control? We'll have our left hand, our right hand, and I've already put some thought into this, so I think the left hand should, the X, Y location should control the location in the sound file, the X controlling whether it's at the beginning or the end or anywhere in between, and the Y controlling between which two sound files are we mixing. if you're in the center of a sound file, it might just play that sound from that sound file. Okay, so we'll call this index and y. I want to put y in quotes. Y position. And the reason that's in quotes is these sound files aren't actually stacked on top of each other. That doesn't, the computer has no idea that I'm interpreting it that way. Okay, so we'll also have our variable for openness. Oops. And this will be whether our hand's open or closed. And I think this should control, and we have a variable like how open our hand is or how closed our hand is. So I think if the hand's open, we should have the indexing be stochastic or a little more varied, a little random. So what I mean by that is if our hand's tightly closed, we're always going to get the exact same location, the exact same index of the sound file, and the exact same mix between the Y location. If our hand's completely open, this will be scattered throughout. We can jump up higher randomly, we can jump left or right through the sound file randomly, and have a large range to jump through. So I'm going to call this will control index stochasticity. And I wrote down reverb as a stretch goal. So we can use the Z dimension for reverb send. Sanity permitting. Okay. All right, so for our right hand, one thing that's fairly obvious, I think, I hate to say the word theremin, but I think, visually, the y-axis should be used for amplitude. The x-axis, actually I have this written down here. The x-axis can control emission rate, so how many grains are coming per second. And the z-axis can control the duration of the grains. And for this hand, openness, will control stochasticity again. Stochasticity of all three of these elements, including elements that we don't have on the three axes. So that'll include the pitch or the speed of the sound file. And I have a stretch goal here of using tilt, so we can use the z-axis tilt, so if you tilt your hand to the right or the left, z being depth in this case, z-axis tilt for synchronicity of the grains. So are the grains going to become at in a periodic pulse, like grain, 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 or are they going to emit like stochastically with perhaps some burst masking, some pulse deviation? So grain, 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 not a periodic emission. So synchronicity. You get to use all of these fancy words when you're talking about granulation. I recommend Curtis Rhodes' book. I've actually, a couple friends of me have made fun of how often I mention Curtis Rhodes, but his book Microsound is fantastic if you want to dig right into some granular synthesis and particle synthesis. Find out what all these words mean from Rhodes himself. It's a fantastic book. I've read it a few times. It's one of my favorites. Okay, so there we go. We have a plan. I'm going to save this on my desktop. Okay, so this is, if I were a more responsible and organized person, I would have a more thorough plan than this. And if this project were much bigger, I should definitely have a more thorough plan. But I think for the size of this project, this plan is thorough enough. I have goals. Looking at these goals, I can think about ways to accomplish these goals, and I can move right along. But depending on what type of personality you have, you might want to organize a little bit more first and keep things tidy. I will note, if you want a project to be a long-term thing, especially in C++, you can get away with more in Max. you really need to be organized. I've had a few projects where I just don't have the patience to deal with anymore because they weren't organized. I'm actually going to be rebuilding one in the next tutorial from scratch and more organized, just because it got too big and things were everywhere. It was really hard to find what I needed. So organization is important. I do believe that this is enough for this size of project, this scale of project. Okay, so we have our project. We need to put this on debug mode. Sometimes it opens like that, and I haven't found out why, but occasionally you'll have to change that to debug. All right, we'll have to do our normal things. And ofxGUI is an add-on, but it is distributed with openFrameworks. So if you go looking for that, don't panic. I think it is available on the add-ons page, but it'd be redundant to download. You already have a copy. I believe this is HPP since I made it recently. And we also need, let's see, ofx leap motion 2.h. And let's just go ahead and let's see what it's complaining about first. See, it's the error doesn't match what it's complaining about, so I'm going to ignore that, give it a compile, and see what kind of shape we're in. Oh, this is always exciting. Abort with payload. This is a fantastic start to the journey. All right. This is a brand new error I've never had. Okay, let's see what our options are. See what this says. Okay, so we can see, we can take a guess at what's failing here. This says libleap is failing. I believe it. So this probably means that the issue, we can narrow that down. Our issue is the leap motion library. Let's go ahead and comment that out and see if we get a successful compile, just to verify. No. Maybe just the fact that we're including it makes it unhappy. Or just not including it, but we have it in our build. I think that's the case. All right, let's look through here. Add-ons. Leap motion 2. All right. Well, I'm just going to go ahead and assume that at some point along the way, I broke ofx leap motion 2 by going into the source and doing things I shouldn't have. I'm just going to download a new copy. Let's go. I always just go to unsorted and Command F. Leap motion 2. This is kind of strange. This is very strange. The emotion 2 doesn't appear to be on here. That is odd. Okay. I can't imagine a reason it would have gone away. But, I mean, we don't have to go through the add-ons page. The add-ons page is convenient. For some reason, it's not there. This looks like the right one. All right, so this is this is what I will have in the description. This might be a good time to show how to the quicker way to add an add-on. So I open. Sorry, I should talk about this. I open Terminal, which is a really fast way to do things on your computer without having to use your trackpad or mouse to mosey your way around. So I'm going to go to my openFrameworks file. So I'm going to go to my Documents folder, list that. I'm going to copy and paste my current working version of openFrameworks. Or you could just type it. So you want to, CD means change directory. We change directory to our openFrameworks folder. We'll list that to confirm we're there. So we can CD, we don't have to list it, but change directory to add-ons. Now I'm in the add-ons folder. So this is basically a terminal-based file explorer. And what we can do here is to directly download this this add-on. So git for git clone. So this will copy the repository. We can take the address of the repository. I just copied this and paste. And so we git clone with the web link, and it will automatically download. Oh no, it won't, because I already have it. All right, so that was a bad example. I'm going to delete my copy, which you can do in the terminal. I forget how. So I'm just above noob status, but not very far above noob status with the terminal. So we can just do the same thing, git clone, and since it's not there, it won't complain. And great. So the way, when I started openFrameworks, I always just downloaded it, went to my downloads folder, changed the title to get rid of the -master that GitHub will add to it, and then manually put it in my folder. When you do it this way, you don't have to do that kind of obnoxious thing. So this would be blaringly obvious to a lot of C++ coders, but the people relatively new to openFrameworks, it won't be. So here we go. I have the current version. Let's see if that will change our situation here. It did not. Oh. This is a little bit painful. Image not found. What image does it need? I don't think that's going to work either. I wonder if my current version of openFrameworks is current. .9.8. Confirmed. Okay, this is a shot in the dark. Let's go to, it's been a while since I've had to do this. Stop this. Well, that was weird. There were two things there. Let's try this one more time. But I'm going to come here, go to my build settings, and there's a small possibility it didn't add the header search. Whew. It looks like it did, though. So this is complaining about loader path dynamic library. All right, I'm going to head back to the project generator, get rid of Leap Motion, and update the project. Oops. Okay, so this doesn't fix our problem. Right now we're just ignoring the problem. So something is going wrong with the Leap Motion library. I don't know what that is. There's a small chance that it was because it wasn't plugged in. But adding the Leap Motion is actually the last thing I plan to do. So in the meantime, I'm just going to, I want to get back at that later so we can make some sonic progress. All right, moving right along. That was an unfortunate. We'll include our ATK add-on and our GUI add-on and double check that that will compile. And it did, great. Okay, so we can keep moving right along. So let's do our normal audio stuff. So we have add an exit function. Add our audio callback function. Audio out, float, buffer, and buffer size, and number of channels. All right, since we've made that, we have to do the use them here. Add our audio callback. I always put it in the same place. Put it wherever you'd like. And standard, we'll add our for loop to fill the vector, the audio vector. I less than buffer size, increment I, and let's just make a current sample and fill our audio buffer. So, oops. I should note that this will be a stereo granulator. All right, so right now we're just outputting silence. We should start our audio stream. A good practice here, this is the first time we've done it, is to use our variables attached to ofxATK. So I have 2 output channels, 0 input channels. Our let's see, settings. Actually, I think I just called them ATK settings. Sample rate and ATK settings, buffer size, and we'll use 4 buffers. Okay, so what this is not totally necessary as long as we're consistent. Oops. But this will verify that ATK is thinking it's the same sample rate as our project. So this is setting the sample rate to 4800 and our buffer size to 512, which is the default values for ATK. All right. So if we run this, oh, we should close our sound stream as well. Run the app. Great. Where are we failing? Oh. All right. So I just I went Java on us all. This is a member of app class. Great. And just to verify that we're going out the right audio channel, let's just do of random negative 0.1 to positive 0.1. So that's just fairly quiet white noise. Quiet seems like the wrong adjective. Okay, so moving right along. So we basically have our, this is really our blank slate here. We have our place to put our audio, and that's just about it. So one thing I know we'll need is a separate document for our grain class. We'll make a class called grain, and that will take care of all the properties, parameters, and states of a grain. And I just know from experience that this I mean, I could add that class, a grain class here, but I know it's going to be very large, so that would not be wise. So in the effort of organization, let's make a new file, C++ file. We'll call this grain, capital G. Also create a header. I'm now in the habit, did not used to be in this habit, but of always calling my documents the same name of the class I put in those documents if it's a one class document. So this will be, the class will be called grain, the file will be called grain.h, grain.cpp. This seems to be the community standard. This will go in the source file. Fantastic. Okay, so we'll also include in this document, we'll need access to ofxATK. And let's go ahead and include this document here. I will separate it from the libraries. And just make sure that including that document doesn't cause problems. Seems to be fine. Also, we could get rid of this. Here we go. Silence is nice. Okay, so we have our class, so we don't yet. Let's make our class called grain. We'll have our public members and our private members. All right, we'll need a constructor. Okay, so we won't put anything there yet. So what will we need as a variable for grains? We'll need a duration, amplitude, speed, which is the speed that we'll play back from the audio file. We'll need a Boolean on-off status. And let's see. Position. So our grain will be a certain duration. This grain can have an age. So are we at the beginning of the grain? Are we halfway through the grain? Or are we at the very end? And that will be useful for determining where we are in the sound file and where we are in our window. I'll do a more detailed video about granular synthesis in a different video, but we do need a window. ofxATK has a variety of windows. I believe most of them were derived from Maximilian, but I will be using a handing window just for all this, and that will not be a variable, so all the windows will be handing. But we do not need to use this as a class or a data type. We can just tell the function, the window function, where we are from 0 to 1 in our grain, or in that window, and retrieve the scalar value back. So we don't need that here, we'll need that in the process function. Speaking of which, I always like to have a function called process, and this will handle all the actual processes. So that won't return anything. Process. We'll have another function to get the sample, and this will return our current sample, which we haven't declared yet. All right, I like to keep these separate. some people seem to not like, because usually when you process it, you just get the sample and you're done. But sometimes you want to get the sample several times without processing it several times. So I like to keep these two things isolated. You have to write an extra line of code occasionally, but that's, I think clarity is more important than being concise, especially when it's not costing any more CPU usage. Okay, so we have our grain. We'll have something outside calling this grain. So we have our parameters, or description of the grain here. Let's go back here, and we'll need some way to decide if a grain should be emitted. ofxATK has an impulse generator. Let's see if it's called impulse. I believe it is. It's called impulse generator. We'll call the variable impulse, or the object impulse. All right, let's make sure that's happy. It doesn't look to be. We should test this impulse generator. What this does is outputs every sample. It'll output either a 0 or a 1. Let's make this a pointer. And so if we gave it a frequency of 10, it will output 10 equally spaced clicks. So let's just verify that will work. Let's set it up here. Impulse equals new impulse generator at a starting speed of, let's do 14 hertz. And we'll process it. And then we'll get the sample. And this will output 0 to 1, so let's go ahead and subtract 0.5 so we don't have DC offset. All right, so this might be fairly loud. Let's see what we have if it compiles. Well, hey, that's pretty neat. Let's go ahead and check out this impulse generator. It has a couple other features that I'd like to explore. If you're on Mac, you can alt-click. I think on Windows, maybe you can right-click. You can on Mac at least. Jump to definition. All right, but if you alt-click, you're brought to the ofxATK library. So here's the impulse generator class. All right, so I made this a little stochastic. You can do pulse deviation, which basically kind of makes it sound drunk or aperiodic. So let's, and there's another thing called burst masking, which is a term coined by Curtis Rhodes in his book, which is just a stochastic masking. You give it a % chance of totally ignoring an impulse. All right, so let's turn pulse deviation up, just to verify that this is working. Impulse, set deviation to, I think I did this 0 to 100 or 0 to 1. We might have to go back. Oops. Oh, it didn't bring me back this time. Let's go back here. Set pulse deviation, my mistake. All right, so let's go ahead and go to the CPP of this. Nothing there. All right. Function must be here then. I haven't finished the documentation for this library, but that'd be helpful, wouldn't it? All right, so does the burst masking. All right, let's try. I bet I did 0 to 1. I like normal numbers. So 0.5. Oops. So these should be very irregular if that's 50% pulse deviation. And we can turn the speed down to 7. And let's just make this 1.0. So these is generally 7 per second, but they should be kind of sporadic. Great. So that works as intended. So that click, each click will mark the beginning of a new grain. So each time you have a click, we'll have to tell our array of grains to start a new grain. So one thing we can do now is do, we have our grain class. So we can do grain. Just thinking here. Make our plural grains an array of size 32. Okay, so we have a bank. This will be our maximum polyphony number. So mileage will vary. We can probably get away with a fair amount. I'm thinking at least 128 grains. After all, they are simply playing a portion of a sound file at a certain speed. So there's not a lot going on, really. We'll have to consider some things. We definitely don't want to put a reverb unit per grain. That would be silly, or even a filter per grain would be kind of taxing. But our current plan, these grains are actually fairly computationally efficient. So let's just let's be bold here. Say we can have up to 128. So we need a way to. We verified that the impulse generator works. Let's get rid of this, and let's make it 4 grains per second. So we should now be getting a pulse every 250 milliseconds. That seems accurate. All right, so no, we don't need to listen to that again. So we'll have an if statement. If our impulse that get sample is equal to 1. All right, so we're listening to that impulse, and we'll need a way to go through our grains and find a fresh one, find one that's not being used. So if we need a new grain, we go through all of our grains. And let's make a definition up here. Below our includes. We'll call this max grains. And we can set this to 128. All right, so we need a for loop, and we'll for and I equals 0, I is less than maximum grains, so 128 in this case, increment I. All right, so we know that if we get a 1, we need to find a grain that's not being used. So what this does, and this is the most efficient way, but this is probably the clearest and simplest way to start, is we start from the beginning of our list of grains, and we go through and find one that's off, find one that's not busy. So we need a member. I believe we have a member of our grain class that's called on/off status. That's a lot of word. Let's call this alive. That's what Daniel Schiffman would call it. And that's a private function, and we'll leave it private, and we'll mind our C++ manners and make a getter function. So we'll have a return a Boolean, get alive. return alive. So this will return true or false. If it returns true, that grain is currently playing some sound. It's currently active. It's currently alive. So we don't want to overwrite it and start over again. So if it returns false, we know that grain's not producing any audio. We can start that with a fresh grain. So we go back here, and if grains, our array of grains at I, if get alive, if it's not alive, I suppose we could have called it dead and not needed this, but moving right along. I like to be optimistic. If it's not alive here, then we'll start a new grain. So right now I'm just going to add that in comments. Start new grain. And then we no longer need to keep going through this for loop. Once we find an active slot, we can exit this for loop. There's no need to keep going. So to do that, we'll say break. You know, before I figured out the word break was here, I always said I equals max grains, and that would disqualify the next loop. But that's a little silly since there's a word meant to do the same thing. All right, so it doesn't like this. Let's see why. Oh, this needs that. All right, so we're asking this particular slot if it's alive, if it is not alive, if it's not currently making sound. We'll have a function to start a new grain. So we'll make that slot alive, start it at the beginning, pick all of the parameters stochastically. We'll have to decide which sound files it's taking from, the amplitude of that grain, the duration of that grain, and then we'll start that grain. So we don't have any way to start a new grain yet. So let's go to our grain class. And let's make a function. I'll put it up here. I'm not sure why, but I will. Void, let's call it start. That's very clear. Start that grain. And if we have a function to start the grain, we should have a function to end the grain. Void end. This function will be actually I'll include that function here. The only thing that ending the grain will do is changing alive to false. However, starting will be a lengthy function, so we should put that in the CPP. Maybe I'm just being lazy. I just don't like retyping all of this just to add one line. And matter of fact, there we go. All right, so let's make our start function. Grain start. All right, so this will need access to our input control. For right now, we could just make it totally random just to test that our start function works. So let's do amplitude equals of random, which it won't like yet since I haven't included the main openFrameworks library. Let's do 0.05 to 0.5. That's a linear distribution of amplitude, which isn't ideal. It should be logarithmic, like our ears perceive sound, but that's fine for now. Let's do speed equals of random 0.5 to 2. And what else should we have here? What other variables do we have? A position should equal 0. We have to start at the beginning. And that's enough for now. You might be noting that we have no way of playing a sound file. But first, as I said, we need to include, I'll put it above my library, include of main.h, almost put ofx, and that should allow us to use of random. So as I said, we don't have a sound file player. Let's get one. So my library has that. First we'll need, so I almost put, this would be, here I'll include my mistake I almost made. Sound file. However, this is giving each grain a sound file. So for each single grain, it will load the same sound file 100, and it'll do this 128 times. So we'll have the same sound file loaded 128 times. This is totally ridiculous. We don't need to do that. So this should not be here. We should give it access to the sound file, but we should not create a sound file for each grain. However, we should have a sound player for each grain. The sound player references a sound file. So sound player. I believe that's what I called it. Let's see if this gives me the green light. It does. All right. I am going to take a quick bathroom break. I'll be right back.